Hey, folks, welcome back to Spring One. I am so excited about the next conversation, and it is on tracing issues in your application. And in this talk, we're going to be listening to both Jonathan Ivanov and Marcin Gradzczyk. Marcin and Jonathan, please take it away.
Hi, thanks everyone for being with us. We are really happy that you choose this session today. And I hope you enjoyed the observability keynote earlier today. And this talk is somewhat related to that. It is kind of an extension of it with much more details about the topic. So if you did not see our keynote, no problem. We will walk you through the problem statements and also the solutions. So to kick this off, let's introduce ourselves. Marcin, would you please start?
Of course. So my name is Marcin Gradzczyk. So Glenn did an amazing job to actually properly pronounce my surname. So I work at the Spring Cloud team at VMware. My Twitter handle is @mgradzczyk, but most likely you can't pronounce it or type it. So go to my blog, toomuchcoding.com, and you can find it there. And I've been working in pivotal VMware for 6 years almost, mostly focusing on distributed tracing, which is Spring Cloud Sleuth. And now this magical Spring Observability project, an initiative. And also I'm fond of contract testing, and I lead the project called Spring Cloud Contract.
Cool. I'm Jonatan. Jonatan, if you are Hungarian. I also work in the Spring Cloud team. You can see my Twitter handle and my blog there on the screen. I also work with Spring Cloud Sleuth and also in Spring Observability, but more on that later. And I am also a maintainer of Micrometer nowadays. So this is our safe harbor statement, and let's get started. Our story today includes two people. We would like to introduce them first. One of them is Joe. He is a demanding internet user who really wanted to search for some memes. And if you have ever given tech support, you might have a feeling what we mean by this. But the other person in this story is Jane, who is a programmer, and she's been developing the meme generating system. So Joe, he wanted to search for some interesting memes here. And at first, things went quite smoothly. He was able to get great results. He was able to find an interesting meme he wanted, for example, this one. Or he was also able to find this one. If you watched our keynote today, you know what I'm talking about. But this happiness did not last very long, because eventually Joe saw this. The blue screen of this here is a little bit of exaggeration, but he was seeing like HTTP 500 meme fails to generate due to server error. So he was quite unhappy because of this. So he decided to file a ticket to the main generation system. Jane, she got the ticket and she was looking at it with the stack trace, but she really wanted to know the truth about what happened under the hood. So if you saw something like this, like Jane did, this is a stack trace inside in a log event. And log events with a stack trace can generally tell you kind of three things. When that particular thing happened in a form of a timestamp, as you can see in the beginning, what really happened, for example, the class of the exception and its message. In this case, it's like a main overflow error, and also the call stack. The call stack is kind of the method calls that led to this particular exception. So these are really important details, but alone, they are not necessarily useful because we are required to know what the application exactly does by reading the source code in order to guess what happened under the hood. So, for example, have you ever searched for an error message in the source code? It's not a really pleasant thing to do, right? Or also, have you ever not found them because they are dynamically built or a different version was deployed in production than the one that you were looking at? So Jane here really wants to know what Joe did. And this is a key thing. We would like to know what exactly happened that led to this error. So let's say this is the logical topology of the meme generator application. And we have 4 services here. They are communicating with each other, maybe a few databases that are not visible here, but nothing complicated, right? So in this case, Jane could just SSH to these boxes and grab the log files, right? So SSHing into production for logs is usually not a good practice, especially from security point of view. And also, these services can have multiple instances, and they can be deployed into different servers in different data centers throughout the world. So telling where the problem happened, it's not really trivial. If you just have hundreds of services or service instances, it's really hard. So should we just buy a bunch of really, really big screens so that we can grab hundreds of windows? It's not right. Especially if you have a Death Star architecture. What can we do in this case? Because today's systems, they can be insanely complex. Tools that we had yesterday might not work today. Also, as far as I remember, one of these images are from 2008. So it's not really yesterday. So Jane, she saw that there is no proper feedback from production. The logs are missing critical information. So we are lacking production observability here. In order to address this, she really wants to address 2 questions. The first one is, what if the applications collect and publish metrics? And also, is there a way to correlate logs so that she will know which log entries belong together? So let's try to address the metrics problem first. Let's say all of our applications collect metrics and they publish them into a data store. Or maybe this metrics backend scrapes them. It doesn't really matter from our perspective. It's the same. So collecting metrics usually means measuring or watching events and also combining the data. And if you do this, you can visualize the data like you can see on the screen. And also you can identify trends and set up alerts. And metrics are aggregatable. And this means that it doesn't matter if you have 10 million events or just 10 in a time frame. You can boil them down to a single or constant amount of numbers. For example, what was the throughput, the error rate, the maximum latency in that particular time span. And metrics are also able to tell you the context of the situation. If somebody complains about an error or about system slowness, you can see how bad is that comparing to other events. So you can see, for example, the blast radius. Is it just one service down, or your half of the system is down? So with this, let's move on to our next topic, which is log correlation. Because we have metrics, we know the trends, we know we can compare the different timestamps to each other, but we still don't know what Joe did that led to this issue. And in order to have log correlation, we need some sort of a correlation ID. And let's call this a trace ID. So when a request comes in, we attach an ID to it. In this case, it's 123. And when the service logs anything that is related to this particular operation, we attach this ID to our log events. So the key thing here, and this is really important, that we need to propagate this information to other services that are called in our workflow. So when service 1 calls service 2, the trace ID travels on the wire 2. And when service 2 logs something out, then we can show that in the logs. And the same trace ID will be attached to those logs as well. And this is the same for service 3 and also for service 4. So with this, we are in a slightly better situation because now we can search for the trace ID and see all the related log events from all of the services that corresponds to that single trace ID. But this is still bad because chronological ordering can be an issue. We can face hundreds of services still, and the logs are not indexed. So it can take a long time to find the entries we need and so on. So let's try to improve this further because we are still not there. So what if we could ship these logs to a log storage and index them there? In this case, it doesn't really matter how many services we have. The tool can take care about the chronological ordering. And also the log entries are indexed, so searching them is relatively fast. And we can use like more advanced queries, saved searches, even visualize the data and set up alerts if we need. And in our case, we can search for the trace ID and we can see what was the root cause of the 500 error that shows seen because of log correlation. And in this case, it was just it was just a timeout. So Jane is done. The problem was solved thanks to log correlation. We can start the weekend, right? Even if it is just Thursday. But let's go back to Joe because he wanted to generate a new meme. So he went to the meme generator again. He typed some query. He clicked the button and he saw this for a very, 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 very long time. And after that, he was eventually able to get the right meme. But this made him sad again because the system was slow. So he decided to file another ticket. And Jane, she saw that there is another issue. The description could be better because like, hey, the system is slow is not very helpful. But now she knows that logs are correlated. So they can help, right? So she was looking at this and she had a couple of questions by just looking the logs that the service outputted. For example, what request exactly are we sending here? And also where? And we are returning a response, but what response? Is this the response for the previous request or is this a different one? And also, did this take like 10 seconds to process? And is using the system clock a good way to measure elapsed time? I can answer that last question. It's not. Don't use the system clock if you want to measure elapsed time or latency. So maybe we can change these logs. And for every single operation, we can basically like add a start entry and the time when it happened. And also when the response comes back, we can add a stop entry into the logs and also write the duration, right? So this is a lot of work. This is a lot of work. And it doesn't even solve all of the problems. So there must be a better way to do this. So if we try to like, look into that, let's say that this is the flow of the request. We zoomed into service 2 because we have operations that we want to observe inside of like services as well. And basically service call just calls service 2 that has a controller in it that receives a request, then passes it to a service component that probably contains like at least 2 HTTP clients, which call service 3 and also service 4. So conceptually, we have a few operations here. The first one is when service 1 calls service 2. Service 2 can also contain other operations as other services can too. And service 2 is calling service 3, another operation. And we have another one when service 2 is calling service 4. So let's call these operations spans. And if you have a set of spans that you can put into a tree, that is called a trace. So a span is just a basic operation, and a trace is a tree of these spans with causal ordering. So a trace is just a set of spans. So if we could have something that automatically instruments our frameworks and libraries, and also records these spans or operations whenever you send or receive a request or response, and also propagates this tracing information over the wire between the services, then we cannot just solve the log correlation issue we saw previously, but we can also record these spans with causal ordering. So we are able to identify cause across services. For example, if a service seems slow, we can tell what operation is causing this. Maybe service 1 seems slow from Joe's perspective, but maybe because down the road, the database of service 3 is slow. So if we go back to our logs by recording the spans, we not only can have log correlation here, we can put a bunch of information about those spans in the logs, like the IDs of these spans, also who called who, when the call started, when did it stop, what was also the duration, and also a bunch of additional arbitrary metadata. We will talk about that a little bit later. So another thing that we can do with this is actually not writing these spans to the logs, but send them to some sort of a span store that was made exactly for this purpose. And that can provide us like better data exploration and visualization features. For example, this one. So as you can see, this is a nice and colorful visualization of about what happened inside of the system. You can have a dependency graph here about all of the services that took part in processing this particular request. As you can see here, in this example, Shop UI was calling 2 services, cart and catalog, and those 2 services are also calling their own databases, CartDB and CatalogDB, respectively. You can also see the whole trace. And if you watch this in a little bit more detail, you can see that there is an indicator for that, for this trace. It's on the top, in that top orange bar, where you can see it took 1.3 seconds. That indicates the whole trace for this operation or for this whole workflow. And also, you can see all of the spans in a nice tree-like views or a tree structure. So you can see who called who. Also when, on what endpoint, what was the HTTP method, what was the response status, and so on. So the different services are also color-coded so that you can distinguish between them. And also, as you can see, that the tool tries to figure out where the requests mostly spend the time. So it is this thin orange line inside of the thicker bars. Those thin orange lines, they indicate the blocking critical path, where the requests really spend the time to complete, which can help you a lot if you want to figure out why is this call taking too long. Also, if you click on the spans, you can get even more details and even more information. And additionally, in some cases, metrics can be calculated from these spans, or metrics can be linked to these spans of traces, and vice versa. So Jane really wants to know what distributed tracing options are out there. What can we use? And she also has a polyglot environment. So she needs some solution which can work for any language or framework. So the ultimate question is like, what what are the latency visualization tools or options she can use to reach observability in production. And that's where Marcin will tell you about these.
Absolutely. Thanks, Jonathan. Let me share my screen. I hope you can see it. So what are the options? Let's talk about certain standards that are out there. So we have OpenZipkin, OpenTracing, OpenCensus, and OpenTelemetry. So what do they have all in common? That they are all open. However, that's not actually true because OpenTracing and OpenCensus are close. They got merged into OpenTelemetry. So what we currently have are two options, OpenZipkin and OpenTelemetry, as certain ecosystems of solutions related to distributed tracing and more. Let's start with OpenZipkin. So it's a mature production-tested solution that has multi-language support, and it's been out there for a long time. So the first release on GitHub took place in May 2016, and it has more or less 14,000 stars. When I say first release on GitHub, I mean that before it was donated to the open source, it was an internal tool in Twitter, which is called Big Brother Bird. Brave, which is a tracer library. Tracer is a solution that takes care of a life cycle of a span. So it knows how to create spans, stop spans, etc. So Brave is such a tracer. It was donated to the open source in April 2013, because before that it was part of SoundCloud, as far as I remember. And Brave has 2,000 stars on GitHub, more or less. And it supports various languages, C#, Go, Java, JavaScript, etc. Many other, of course, community-driven. So what about the new shiny OpenTelemetry? So it's new, multi-language, and CNCF oriented. And recently there was an announcement they are incubating in CNCF, as far as I remember. So OpenTelemetry Java, that is an implementation of a specification of OpenTelemetry, has around 900 stars on GitHub, and the first ever release took place in November 2019. Now, the specification itself has around 1,900 stars, and the first ever whatever release, a milestone release, happened in June 2019. The GA releases, however, took place at the end of 2020 for the spec, and for the Java part at the beginning of 2021. And now there's also the Java instrumentation part, which is not GA at all yet. They are in this alpha mode. And when we're talking about GA, we're talking about tracing on, because there's also metrics and logging. Those are not GA. Speaking of which, OpenTelemetry wants to address those problems together, logs, tracing, and metrics. And they do support various languages as well, Java, C#, Go, JavaScript, etc. So there are various latency visualization tools, one of which is VMware Tanzu Observability by Wavefront. So you could have seen those pictures throughout our presentations, that the screenshots are coming from the Tanzu Observability product. You could have seen those also during the keynote. If you have a Spring Boot application and you use the Wavefront starter, you get an option to use the Tanzu Observability product for free. So go ahead, check it out. If you want to use something else, there's OpenZipkin, that is a project as such that allows you to visualize tracing information. It looks like this. And there's also Jaeger, that was heavily influenced by OpenZipkin. We have also APMs, so application performance management vendors, monitoring vendors. Sorry, New Relic, Datadog, AppDynamics, Dynatrace. There's a lot of those. And typically what they do, they have, of course, dedicated UIs. And typically they work with an agent. So you plug in an agent and you can get say additional insight into your application. So what about Java and Spring? Jane wonders. She wants to know if she can use distributed tracing with Java and Spring. So the answer to that right now is to use Spring Cloud Sleuth. So it provides distributed tracing support if you're using Spring Boot applications First release took place in October 2015. Now we have version 3, but before that, when we had version 2, we worked directly with OpenZipkin Brave's API. So Brave was all over the place in our code base. And in version 3, we decided to create our own API from which we can bridge to Brave. That was specifically the case because we wanted to have different options of tracers, one of which is OpenTelemetry. The idea of Spring Cloud Sleuth is that you plug in the library in your class path, you configure it, and you do nothing else. It should work out of the box. It should be completely transparent to you. So how does it really work? We have different options of, let's say, exercising certain actions in your app. For example, messaging, batch, HTTP, whatever. Let's focus on the HTTP. So an HTTP request comes in, and Spring Cloud Sleuth has instrumentations for all sorts of projects. I mean, really a lot. And with version 3.1, we've added even more support. So there's Sleuth instrumentation that is using Sleuth API. So the abstraction of a given tracer. And we have the API bridges from Sleuth's language to the given tracer. So we have out-of-the-box support for OpenZipkin Brave. And then we have an incubating support for OpenTelemetry. Why is it incubating? It's because OpenTelemetry is not yet GA. We are using both OpenTelemetry Java and OpenTelemetry Java instrumentation. And since OpenTelemetry Java instrumentation is not GA, we are still in incubating mode. Whatever is picked, at the end of the day, you need to send the spans to a dedicated span store, as Jonatan mentioned. So we support out of the box OpenZipkin and Tanzu Observability. However, both via Brave and OpenTelemetry, you can access their dedicated reporters and send it out to various other locations. So what about metrics? What is out there for Java and Spring? And the answer to that is Project Micrometer. So what Micrometer gives you is a vendor-neutral applications metrics facade. The first release happened in February 2018, and it's an extremely popular metrics library for the GVM. So the slogan that we think describes it the best is what Micrometer presents on the website. It's like SLF4J, but for metrics. So you have a simple API, facade, a certain abstraction that abstracts the popular metric backends. You don't have vendor lock-in. You don't have to use specifically the API of a given vendor. No, you use our facade, and different metric backends can be plugged in. If you add Spring Boot Actuator to the class path, you get Micrometer out of the box. And a lot of Spring projects are being instrumented using Micrometer. So we eat our own dog food. However, the community also likes micrometers, and there's a lot of third-party libraries that are using Micrometer to instrument their code. And when we say that we support the most popular metric backends, we mean it. So we have quite a lot of those. And now, Jane wonders if there's a Spring native way of doing observability. So here we are more than happy to announce with Jonatan something called Spring Observability, which is a new initiative. And what is that? It provides Spring native approach to observability. And initially, we were considering making it a separate GitHub project. But after just quite a few discussions within the Spring team, with Jürgen Holler especially, we thought that it makes most sense to actually put it in Spring Framework Core. So Spring Observability will become a part of Spring Framework Core 6. It provides various things, but let's focus on two main ones. It gives you the Recorder API. So it's an abstraction over measuring things within your app. So if you want to measure, let's say, the duration of things, you can use the Recorder API. If you want to instrument something, or you're interested in measuring the duration of something, and you use the Recorder API, the Recorder will create a recording to which you can plug in various listeners. The main ones are those for metrics and tracing. So if you use the recorder API once, you get metrics and tracing out of the box and more things that you can plug in by yourself. So you do it once and you get multiple outcomes out of it. And since we believe that it makes most sense for the users to provide their own things in general, to provide an easy way to extend how Spring works, this solution is highly extensible. And that's because you can register additional listeners yourself. But we also provide tracing abstraction. So imagine this being like Spring Cloud Sleuth, but without Spring Cloud, because often was the case that somebody said, hey, we don't want to use Spring Cloud, we have a Spring Boot app, or we don't even have a Spring Boot app. So we hear you, and the tracing abstraction is moved to Spring Framework Core. What is also important is that instrumentation happens in dedicated projects. So no longer do we have a, sorry, I'm gonna turn on some light. Instrumentation happens in a dedicated project. So no longer do we have like a God project like Spring Cloud Sleuth that has, all possible dependencies in it. That's no longer the case. We will provide the API. We will provide some core instrumentation of core components, but further on, the instrumentations will happen in dedicated projects. So how will it work? Let's focus on the HTTP example. In Spring Framework, in the Spring Web module, we will provide let's say, instrumentation of the web part of, let's say, we introduce certain filters that will use the Recorder API from the Spring Observability initiative. And Spring Observability Recorder API has two types of listeners coming out of the box, the tracing one and the metrics one. So whenever recording starts, stops, there's an error, the given listeners, their methods will be called. So for tracing, we will then call the abstracted tracing API, so the one that we will port from Sleuth and modify a little bit. In terms of metrics, we will use micrometer. And then we will, let's say, delegate the work to the given tracer implementation, for example, Brave or OpenTelemetry. And in terms of micrometer, we will leverage meter registry, so that finally we'll be able to send out spans or metrics to the dedicated span or metric stores. Finally, some code. So how does it really look like? So we have a recorder bean that will be injected, and we say, hey, we want to create a recording. And now we believe that we can have two types of events that happen, let's say two types of actions. Interval ones that take time, and certain instantaneous ones. So we believe that we can describe them by events. So there's an interval event or an instant event, right? So here we can see that we create a recording for an interval event whose name is important calculation, right? We can tag the recording with certain information. For example, calculation type is tags. And what is important to see here is that we provide cardinality low. What is this cardinality? It means that there will be not a lot of values for this particular tag. So cardinality low. Whereas for the user ID, we can have a lot of different users, so the cardinality is high. And why is it important? Because depending on the level of cardinality, metrics and traces will behave in a different way. And we start the recording. So we start the calculation of the duration of execution of the calculation service and its calculate method. Now, if an exception happened, we will attach the exception to the recording, and finally, we will stop it. So it's as simple as that. You start the recording, you tag it, you can provide a high cardinality name if necessary, you start it, you execute a method, you register an error if there's one, and you stop it. So Jane wants to see Spring Observability with Tanzu Observability and log correlation in action. So let's see if the demo gods will be with us today. Most likely not, but let's keep the fingers crossed. So I have the 4 apps running on my machine, and I will now create a presentation service that will call service 1 and will leverage Spring Observability. So let's do it. I'm excited. So let's go to Spring Initializer and let's create a project called Presentation Service. Since with Jonatan, we, as you could have seen during the keynote, we believe in YOLO approach. 254 seems like a 2GA of a version of boot. We will use snapshots. And I'm lying to you. We're not going to be using Spring Boot snapshot. We have a dedicated snapshot version of our own, specifically for Spring Observability. But you'll see that in a second. So we will use web. We will use actuator. We will use, what else will we use? I think that's pretty much it. Let me double check because, yeah, that's it. Let's generate it. I mean, what can go wrong? Let's unzip the project. Oops. Okay. And now I have recently quite a few problems with my IntelliJ installation. So hopefully it's going to actually even work without spending 25 minutes on indexing. Oh, indexing dependencies, of course. But let's play around with the POM because we have to mess things up a little bit. So as I mentioned, we are not going to be using snapshots. What we will be using is observability. Yes, I want to edit it anyway. Thank you, IntelliJ. Observability snapshot. Like I said, we have a dedicated snapshot version. And if we are using this special version of Spring Boot, specifically designed to work with Spring Observability, we can add a special starter, which is Spring Boot Starter Observability. And what it does, it's providing micrometer, it's providing setup auto configuration for Spring Observability with the recorder API, the whole tracing approach. It has everything there. Since we will be sending out logs to logs.io, which is a instance of Elk Elasticsearch log/Kibana running in the cloud, we also need to provide that, logs.io logback appender and log/logback encoder. Now I will try to refresh it. However, I see that I'm indexing JDK 16. So we'll see if I ever manage to actually finish this. So in the meantime, I will be assuming that everything is working fine. And what I will do first is set a couple of properties. So the name of the application will be Presentation Service. Now, for the sake of the demo, I'm exposing all management endpoints. If I have any problems with things running in the cloud, I will at least try to show you that locally. I'm connecting to a demo instance of Wavefront, so I'm providing the URI. I have a dedicated token for this. And here we can see that I am providing the name of that set of applications. So service 1, 2, 3, and 4, they are all running under the name called Sleuth Documentation Apps. I should have changed this for this demonstration. And here we have the name of this particular service, which is Wavefront Application Service. Of course, by adding the starter to observability, I'm adding also Wavefront. So what I'm going to do next is I need to have a dedicated logback Spring XML configuration where I am leveraging the logs.io logback appender to send out my logs to the special URL for logs.io. And I am presenting, let's say, the way I would like the logs to look like. Right, so that way in Elk I can cut them into pieces and let's say see the already cut logs. Okay, so enough of configuring. Let's actually code something. So we will be for sure using REST template for sending out requests. So let's start with that. Fine. And now I will be using. I need to have a controller. So I have a presentation controller. Let me add the loggers, myself for J, so be it. Okay, and here what we have is REST template service. So I don't want to call any things directly in my presentation controller. What I want to do is, let's say, log some information on the incoming request and then delegate the work to the service as such. So let's now write the service. It's going to be really cool to show you that you're the first ones to actually see the new recorder API. So REST template service is a service annotated class that has the recorder interface injected. It comes from Spring Observability. And now let us import this. We are creating a recording for an interval event that is going to be called calling start. The method name tag is call because the name of the method is call, and it's of low cardinality because there are not many options there. Now we pass a random value to the service call, so the method param was going to be of high cardinality because it's going to change a lot, and we provide a high cardinality name for this particular recording. So this is the default name, calling start, but we want to have a high cardinality one. Here we could do a lot of stuff, and over here we are using the other recording, which is the instant event. So here we say that at this point of time, we want to emphasize that a calling start before call event happened. Like, record this and let's move on. So what it will do is for metrics, it's going to create a counter, and for tracing, it's going to annotate a current span. Here we are sending out the request to service one, and over here we are, if there's an exception, we will store it, and here we are doing a stop after this call has been made. And that's as simple as that. So now what I will do is pray to the gods of demos so that they don't mess up my demo. So let's run the project, the app. The app seems to be starting. Okay, that looks fine. That looks fine. Bear with me. So now, if I send out a couple of requests, things should work, and they do. So we have presentation service, hello from service 2, response from service 3. Great. So let's now send out a couple of more requests. Okay, good enough. So what we see here, okay, so if you ever use Spring Cloud Sleuth, the change logging statement should not bother you. So what we have here is application name, the trace ID, and the span ID that Jonatan also mentioned. So every single time you have a new trace ID and a new span ID because we have new traces. So what if I try to copy this? I will go to my installation of Ivanov, and let's see if that works fine. And it works. So we are in good shape. At least one of the 3 things works. So we've managed to find all the logs from all 4 apps, starting with presentation service. So we've managed to successfully propagate the trace ID for various apps through the web filter through the REST template, so things work fine. And we have put it in the chronological order, and we can now reason about why things didn't work or why things are working, etc. So that was easy. Now let's go to Tanzu Observability. And here I have a dedicated dashboard for my app with a live view. Okay, so things are working. So calling start max. So we have metrics coming here, and I have provided a max from the 2 last hours. So we already have metrics. Now, if I go back to the terminal, let's go over here. If I send a request to actuator metrics, calling start before call, you see, we have a metric with a counter. Great. If I, what was the name of the metric? Let me double check. I don't remember. Calling start. So if we do calling, what was it? Calling start. Well, actually, let's pick metrics, and I will find it because I don't remember. Calling start. So if we go to calling start, was it with a dash? Oh, with a dash, sorry. We see that we have the counter, we have the total time, we have the max time. So we get metrics out of the box as well using the recorder API. Now, if we go to the trace view, if we make it live, if we show the most recent ones, here we can see that the presentation service is within those 5 apps. And here we can see a span whose name is calling start, blah, blah, blah. So this is the high cardinality name. So for metrics, it's just calling start. And for tracing, it's calling start with a random value over here. And I also remember that we have added an annotation, an event. So if we go here, we see an annotation called calling start before call. So we in metrics world, we got a counter with this name. And in the tracing world, we have an annotation with that name. Of course, we have standard tags like method name, method param that we put there in the tags. And so we got them in over here, as far as I remember. Yes, method name, call, right? And we don't have the method param as a metric tag because it's of high cardinality, and we don't want such metrics to be there. So much to my surprise, I'm shocked. The demo worked fine. Great. So let's get back to our presentation because we will be concluding it shortly. So that was it. That was the short demo. Now there is a short, let's say, small disclaimer that the API we've shown you today is in progress of being developed. So don't be shocked if you try out our snapshots in a week from now and nothing compiles, because we are heavily working on it. However, we are planning on releasing, I think, the first milestone quite soon together with Spring Framework. So then we would love to have your feedback. And this is going to be the moment to get your feedback in order to work on the API and make the API as good as possible. So that's it from our side. You can always contact us on Twitter. You can follow us on Twitter. My Twitter handle is @mgrzejszczak. My blog is toomuchcoding.com. And Jonatan's Twitter handle is Jonatan_Ivanov. And the blog is developers.com. So that's it from us. Thank you so much.
Thank you.
Well, Jonatan and Martin, oh my gosh, that was awesome. Now I want to go and play with it, and I got to tell you something right out the gate. I saw you put the words batch there, and the fact that capturing metrics and stuff from batch apps, brings something really happy to my heart. So, gosh, guys, thanks.
Good, because you'll have to instrument it yourself, man.
I'm sorry, dude, you're breaking up. You're breaking up. I'm sorry, I can't hear you. What was that? Was that you were going to do that for me? I know. Oh gosh, I am so looking forward to it, and I can't lie to the folks out there. I kind of knew where they were going to bring this, and I was like, I want to tell everybody, but I gotta wait. So I am so glad y'all made the announcements on this. This is going to be so exciting for all of our users and all the features that are coming up. So with that, folks, I'm going to go ahead and say, please join Martin and Jonatan in the Zoom chat, okay? And ask them the questions, because guess what? Not only can you ask questions, but if you might have a little, maybe, some of their questions may help them add features in the future. And so feel free to join them there. And there's in the Zoom chat, you can go look at their Zoom chat via the Slack. It should have a link in there. And I am most proud to say that we are about to have our next presentation up called Building Layers of Defense for your application using Spring Security Framework, brought to you by Neha. And folks, I am going to be handing off my MC duties to Ivan, and you're going to be so excited to be working with him. With that being said, your next talk will be at 2:05 p.m. Eastern Standard Time. I hope you enjoy the rest of Spring 1 and have a great day.